I'm George Ellis. I'm Emeritus Professor of Applied Mathematics at the University of Cape Town in South Africa.
And Emeritus Professor, that means you're retired. Is that correct?
Well, I'm pretty busy. I don't give lectures anymore, but I'm working away doing research, publishing papers, going to conferences.
So once a professor, always a professor.
Yeah. Well, Cape Town, the first real science that took place was when the Herschels came here, famous astronomers from England, and because they'd done a lot of observations in the northern hemisphere, they needed a southern hemisphere observatory, so they came and set one up out just near Kirstenbosch Gardens in the place which is now Herschel School, and they did some really important observations of galaxies from the south. And then William Herschel was also a botanist, and there's amazing botany in Cape Town, so he started botanical connections. And incidentally, Charles Darwin stopped off here on his trip around the world, and he had very important interactions with the Herschels about geology and about botany. There's been a lot of stuff, but there's just two things that I might specifically mention. The first heart transplant took place in Cape Town with Barnard, and that was revolutionary. But what was far more important was the first CAT scan took place in Cape Town. Alan Cormack, who won the Nobel Prize for that work, and that was the beginning of medical imaging, and that has transformed medicine completely across the whole world. Or PET scanning, CAT scanning, and all of that comes from the work that Alan Cormack did. And it's made an incredible difference, because nowadays you can see inside a patient what is happening instead of having to cut them open in order to find out what's happening. So it's absolutely transformed medicine. You know, I think it came because I had an electric train. The electric train got me to understand about how electricity works, and I used to wire things together. I also had a little stage that I did puppet performances on, and I rigged up an electrical lighting system that had coloured lighting where you could dim the lights and turn them up and so on. So I actually got interested by practical work with my model train set on the one hand and this model stage on the other hand. My current main research is about causation in complex systems, and the point about this is that we're each made up out of atoms, which is protons and electrons put together to make nuclei. They form atoms which get together to make molecules, biomolecules, cells, organs such as hands, arms, legs, heart, lung, and so on, and the individual people, and then the society in which they live. And the question is, how can it be that a mind can emerge out of the interactions of protons, electrons at the micro level? Somehow or other they produce a brain which can produce a mind, and that's a really, really interesting topic about which I've written a book about that. And the key thing about this is that most of my physics colleagues and a lot of biologists think that all causation is bottom-up. In other words, it's the interaction between the electrons, the protons, and so on, which determines what happens in the molecules, in the cells, and so on. So if you could understand enough physics and could get a detailed enough analysis of the brains, the neurons, the synapses, and so on, in principle, some of my colleagues think you could predict what I'm about to say on that basis. I don't believe that. I believe that things work the opposite way around, that there are emergent levels of complexity, and so, for instance, the psychological level is real and works at its own level, and in fact causation is the other way around. It goes from the level of thought down to what happens in the synapses and a nerve. So for instance, if I decide I'm going to move my arm, I move my arm. I made a decision at the psychological level. That sends signals down my arm through the nerves, through to causing electrons to move in my muscles, which made my hand do what it did. So causation is actually top down as well as bottom up. Well, one of the really interesting things is that the universe has to be of a rather special character in order to allow life to come into existence. This is what's called the anthropic question. And so I've written quite a bit about the philosophy of cosmology, and with quite a few of my colleagues, we've had lots of debates going on about what the special nature of the universe is that allows life to come to existence. For instance, if there was no galaxies, there would be no stars and planets, so there wouldn't be any people. And so then what are the conditions which allow galaxies to come into existence? So as a theoretical cosmologist, we can think of other universes that could have existed. And the discovery, which is a real scientific discovery, is that most universes we can think of, if we start modifying the laws of physics, alternative universes, most of them wouldn't allow any life at all, because there wouldn't be any carbon, there wouldn't be any galaxies, and so we wouldn't have the materials out of which life could come into existence.